Okay, in this video, we're going to look at example 5 out of chapter 3, section 3, the notes. We've shown on the board already in class how to get the equation that I'm going to type in shortly. So I'm just picking up from now. We need to find how to maximize this equation. So the first thing you want to do in your calculator is go into y equals and type the equation that was given in class. And we got up to the step where it said, we started off with a negative sign, so we had like negative 18 cosine of theta. And then, let me just type what we had, and then I'll show you where we need to go from there. So we had negative 18 cosine. The mode that we're in right now, we need to use the variable button, and the variable is going to type x, and it doesn't really matter whether you have x or theta. I know on our papers we have theta, but that's not going to be a big deal in here. So we had negative 18 cosine theta times negative sine of our variable plus or minus, and obviously I can't type a plus or minus sign, but here's the first part. The problem says that the path of a projectile propelled at some angle is, the equation, and then it says that our variable is going to be measuring the horizontal distance that it travels. And so therefore our equation is starting at wherever it starts from is considered to be 0, and it's being shot out, so it's moving some positive horizontal distance. So then when you have the plus or minus sign, the negative is not going to come into play here. So the only thing that we care about is the plus sign. So then from after this, we had the square root of sine squared of our variable. So sine of your variable and then squared. And then you need to type plus 1. Come over here, close your parentheses. So this is our equation that we're typing in, except for one little change. The one little change that we're doing is the negative out here is going to get distributed. So you have a negative times a negative, which makes a positive for this negative sine x. So I'm going to be deleting this negative sign here and the negative sign here. And so to do that, I need to move my cursor over, hit the delete button, move my cursor over again, hit the delete button, and the plus or minus sign that I originally didn't have here, I decided to go ahead and put it in here just to say that when I distribute the negative sign, the negative times the positive would make a negative, and the negative times the negative would make the positive. But again, you only care about the positive solution because you only have positive distance. So either way, even though we're distributing the negative, the plus or minus, the minus sign is still the one that's going to go away. So your problem that you eventually need typed in is just going to say 18 cosine x parentheses sine x plus the square root of sine squared x plus 1. And you can see I have that whole equation in here. Just real quick to look at it, basically you would hit zoom 6, that's your standard window. And this is what you see. And the window that we're looking at, obviously you can't see anything really that means anything to you. But since we're trying to maximize this function, the first thing that you should think of when you see maximum or minimum is I need to know the derivative. And I need to know when the derivative is equal to 0. So the derivative is equal to 0, obviously at the maximum or the minimum values, but I can't see a max or min because my graph goes off the screen. So I need to adjust my window to see higher and lower on this function. So you can see that right now our graph, the default window, only goes down to negative 10 and up to 10. You want to change this to negative 30 and positive 30. And it's going to make it easier to look at if you change the scale from 1 to some larger number, and I just chose 5. And now when I hit graph, you'll notice that you can see the actual whole function. And because we are starting at 0, for our graph and shooting we're propelling some projectile out, the function starts here at this location on our graph. Nothing to the left of the y-axis matters. So the first time we see a maximum is here. And notice that whatever maximum we get, it just repeats itself every cycle. So we just need to find this time right here that there's a maximum. So the way you do that is you go to Second Trace, which opens the Calculate menu. You're going to calculate a maximum, so choose option 4. Your left bound, you need to have your cursor somewhere to the left of the maximum, and it already is, so you can just hit enter. For your right bound, you need to have it somewhere to the right, so you can use the right arrow to cursor over. Obviously now I'm past the maximum. Hit enter. The guess doesn't matter, just hit enter, and then it will tell you the answer is 0.615. And our mode that we're in right now, let me show you that. We are in radian mode, and because the problem on their paper says theta, then you need to convert the radians over to degrees. So going back to the main screen, I'm going to show you how to do that. The last most recent value of x that we looked at is currently stored as the x variable. You can see if I type x, I see that same 0.615. And as soon as you do something on your graph, you change the function, you move it around anywhere, this x variable is going to change. But for right now, it's the number that we need. So we need to take x and convert it to degrees. And the way you do that is that you multiply by 180 over pi. And so doing that, we get 35.3 degrees. So the question on your paper said, what value of theta will produce the maximum horizontal distance? And the answer to that question is theta needs to be 35.3 degrees. Will maximize the distance that the projectile can go. So that's how you finish off example 5 out of chapter 3, section 3.